around it is. There's the recording starting. So what is Linux? Linux is, I might just read from this. I'll try not to. It's an open source monolithic kernel. That means that it is so a kernel is the core piece of software that runs your computer, right? It's as I say, it's essentially a collection of drivers and a scheduler, right? Linux tells your CPU how to interact with your hard drive and how to load things into your graphics cards, memory, and stuff like that, right? Like that's basically its purpose, and it schedules tasks. It handles file system activities, right? So like not like you browsing the file system, but actually reading and writing files to the specific format. It handles that kind of stuff. The rest of the software that makes up what we would think of as Linux, it's actually a collection of a whole bunch of different tools and utilities from a whole bunch of different people. The most notable projects are the GNU project, which provides a whole bunch of base system tools, compilers for C, C++, weird ones like D, and I'm trying to think a bunch of other ones, and assemblers, linkers, all that kind of stuff, alongside stuff you wouldn't really think of, like command line calculators, things like that. And then there's systemd, which is your init system that launches all your other programs. And these to kind of come together and make the basis of what Linux is. Any questions so far? I suppose I should stop there and ask.
What's a scheduler?
That is something that decides what tasks are going to run on the CPU and when. So your computer might have, say, 4 CPU cores and 500 running processes, right? It's got your desktop, your web browser, your email, and all these have 50 processes related to them because it's drawing on the screen and it's doing all that. So something has to decide what runs and when, and that's one of the core jobs of Linux. That's pretty much one of the things that's most important for is deciding what runs and when. Another thing I should have put here is it handles process security. So it handles segregation between different parts of the system. Say, when you have your banking open in your web browser, you've got your bank app open, and then you've got an online game running in Steam. It's going to be in charge of separating those two so that the hacker in the online game can't steal your banking info, right? That kind of stuff is what Linux itself is doing.
And
Anyone
I guess
else?
follow-up question, how is that
Oh, sure.
different than Mac or Windows?
Sure. It's only really different in like fundamental execution. It's not so much different in what it's doing, right? Like Windows is also providing that layer of separation, as is Mac OS. The means by which they do it are different, and that's really like a kind of technical question. I would say the most notable difference about Linux is that it's entirely open. Um, Unlike Mac OS, which is mostly closed, and Windows, which is functionally entirely closed. Which means that there's a lot more broad use to it than, say, the Windows kernel. Because the Windows kernel, you wouldn't really deploy in, say, an edge case like a Raspberry Pi running, I don't know, in a weather station in like a park, right? Or in a autonomous vehicle, because of the fact that it's so open and easily modifiable. People make a bunch of like it itself can be built for a whole array of things, and it can be modified to an even larger array of things with minimal effort, which is not true about Windows and Mac OS, which are pretty much exclusively desktop kernels, with the exception of the Windows, whatever it's called, server, I think it just is, which is also basically still just targeting like your desktop computers, you know? Um, but for example, right, Linux powers all Android phones and Chrome OS devices, which I was going to get to a bit later, but that's just not really a use case that the Windows and Mac OS kernel are set up for. Anyone else? Or more questions on that?
So how does your scheduler decide what processes to run? If you're running, 30 different processes and maybe your RAM is spiked up, what sort of decisions does your kernel have to make to make sure that you're running your Steam game at the same time as your 14 Chrome browsers doesn't crash your computer?
This is a fun and technical question, and I'm going to try and answer it in a reasonable amount of time. So, the default scheduler is a round robin scheduler, which basically means if you've ever heard of round robin in, say, a gaming tournament or something like that, it's going to create a list of 1 to infinity of every single process, probably 0 to infinity. No, it actually is 1. Yeah. So 1 to infinity of every single process. And then it is going to walk through one by one each process in that list and see if it has something to do. And then it's going to run it for an amount of time and then stop running it and replace it with the next process in the list and move that process to the bottom of the list. That's the default scheduler. That's used for like server workloads. It's not amazing for, say, something like gaming, music production, video workloads. It's not bad for. But basically anything real time, you're going to feel it. For browsing the web, you won't really notice. But luckily, the openness of the Linux kernel gives us the solution to this, which is a bunch of people make custom schedulers. The Zen kernel comes with a custom scheduler. Who else? The Xanmod kernel comes with a custom scheduler. There's several more. Either way, people have made a whole bunch of very interesting advanced solutions to this. And I'm also greatly oversimplifying the default round robin scheduler. It also has, say, priority for kernel tasks over system tasks, and you can manually assign priority. It can tell like how much work a task is trying to do, and it can move it up, things like that. But I hope that's a good, simple explanation of what it's doing and why. If we have nobody else, I'm going to go to the next one.
Yeah,
Actually, I'm
go
just going to
ahead.
go. Yeah, I'm just going to go to the next one. So, distributions. Did I spell distributions wrong? No, I think that's right. If that's wrong, I spelled it wrong everywhere. Anyways, so because of the open nature of Linux and the fact that this software is so separate from the operating system, we have what are called distributions, right? You've probably heard of some of these. The major base distributions would be like Debian, Arch. I put Gentoo in there because I love Gentoo. And then there's kind of branch off distributions of those. I guess I'll explain a little bit. So I should roll back. The reason you would choose one distribution over another is that they have different design philosophies and sometimes different software collections. Usually the design philosophy is the most important distinction. So the two first ones listed here, Debian and Arch, are a great example of conflicting philosophies, which is labeled down here as stable versus rolling releases. One second. Ooh, drink too much water, I guess. Anyways, a stable distribution attempts to not update packages very often. Packages are your software. So what it will do is there will be a major version. This is basically what both Windows and Mac OS do, right? So you can think of it like this, right? Windows puts out Windows 10, right? And Windows 10 has all these big changes to the File Explorer, big changes to the settings menu, big changes to the whatever, big changes all over, new features, new whatever. The stable distros, so they're called. This doesn't have to do necessarily with stability in like my stuff is stable and not crashing sense. It's just as stable as in things aren't changing. Your stable distros follow that kind of philosophy where right now I'm running on Debian 13. You can see I used the Debian wallpaper for this because it was in the default slides. I think it was great. Debian is a stable distribution. This is 13th version, so all of my package versions are pretty much going to stay stable except for like security updates, right? So web browsers get updates because of security issues and things of that nature. But all of my, say, audio packages, because I do a bunch of music, they stay the same every update until Debian 14 comes out. In which case, a whole bunch of pretty much everything will get all updated at once. Arch is the opposite of that. It just runs the latest version of everything all the time. Basically, every day you can update your computer with like 10 gigs of system updates where like the whole system is reinstalled. It's pretty crazy. Remarkably stable despite what I just described. Like you don't really get crashes and stuff very often, even though you'd think you would, given that. But
Does Arch have like version numbers? Like Debian has like actual version numbers, like Debian
yeah,
13. But does Arch have, because it's a continual rollout.
yeah, it does. It kind of disguises them, though Debian does the same thing. I'll talk about that a bit more when I get to package managers, I guess. But like you would install, say, Python, just like pacman-s Python, right? And then it would grab Python 3.14, I think is the latest. And then the next time an update happened, when Python 3.15 came out, it would just auto install Python 3.15. You wouldn't have to like specify, but you can specify as well. You can say specifically grab Python, 3.13.9 or whatever. I want that version of Python and I don't want any others. You can do that, but it's usually you don't want to. It's really rare that you want to do that, basically. And then the last one of the base distros I'm going to mention, because I think it's fun, is Gentoo, which takes the idea of open source software to its logical conclusion. And the Gentoo distro is basically a C compiler and a Python binary and a bash terminal, right? And that's it. That's like all it comes with. And then you're expected to build all of the other packages from their source code, which it makes easy. This isn't a hard task. You just like package, install, whatever, right? But yeah, it takes it to the logical conclusion of open source, which is just build everything every time you install a package, recompile it for the system with optimized for the system and all that kind of stuff. It's pretty funny. Any questions so far?
So
I'm curious.
Gentoo,
Uh,
sorry.
it's interesting you said that about Gentoo because when I first told a friend who is a Linux acolyte that I wanted to wipe one of my daily driver laptops and boot Ubuntu or something like that, he said, "You can do that, but get Gentoo if you want to learn how Linux works." And now I understand a little bit more about what he's saying. You you have to understand each package as you deploy it, basically. You have to intentionally choose every single package they're using on your system.
Yeah, and you get a
And
lot
Gen
of
2,
very
is it headless or does it have
Oh, you can build a full. I mean, you can
Okay.
install Steam on it and play games. I used it for my music studio for a while. I'm gonna go back to it. I moved to Debian because I wanted to test a whole bunch of stuff. And now I'm done testing what I needed to, so I'm gonna move back to it. It's just like when you have to compile things from source all the time, it does become a pain to test stuff. And to like switch stuff around.
So
But
in these
Gentoo has.
massive data centers, Jake, sorry to interrupt, but
Oh god.
what distro do you think they would be probably leaning towards the most?
Red Hat Enterprise Linux, I probably should have added here, is what I would advise a big corporation use if I was in the dark asked right this moment, right? Like if someone came up to me and said, "Hey, I run X multi-billion-dollar national or international firm and I need to run a Linux distro. What should it be?" I would just be like Red Hat Enterprise if I didn't have any follow-up questions. Like if I couldn't ask any other things. Simply because it will give you pay their enterprise license fee and then you have like kernel devs on tap, right? You like call these guys up and they put you on the phone with like the guy who made the software that you're having issues with, like that kind of situation. So that's what I would have to advise to like a big corporate environment in the blind. But otherwise, I would need a whole bunch more info. But like, if we were to start going into hypotheticals of, oh, what if they have this? Oh, what if they have this need? Oh, what about that? That's fun. I'll totally do that. But I think we should do that later.
I can definitely attest to Red Hat being used in multinational companies. Gentoo,
Yep.
you said something interesting about Gentoo is that it's basically just a, a kernel and then a compiler.
No,
And
no, it
that,
doesn't come with a kernel. It expects that you boot a different Linux distribution, and then it does ship like their Linux distribution, right? But it doesn't actually come with a built kernel. It's only a compiler chain and a Python interpreter.
hold on, actually, so walk me through that. How do you start compiling stuff if you never get a kernel? You have to like plug in your puppy Linux and then
Yeah,
start it with that.
yeah, and they do ship a like a Gentoo CD, but that's not really what it is. It's like you don't actually install the software from the CD onto your system. The CD is there so that you can run the C compiler and build the software onto your system.
So one of the things that, from my understanding, Gen 2 is particularly good at is unusual situations. If you
Yes.
have, um, maybe you have some sort of computer that is like very old or has a different type of architecture or has a very specific use case, or something that you may not even consider to be a computer, like your microwave.
Yeah,
That
I'll give two really cool examples. One is me personally. My first a fun experiment I did is that I made a song with a bunch of plugins, a bunch of software in Gentoo on my desktop that's sitting right there that I'm not going to point the camera towards. It's just an x86 as a Threadripper, standard desktop. And then I took my Gentoo config files, right, and none of the binaries, and the project itself, the music project, with all my MIDI and settings for all the synthesizers and whatever. And I moved that to a Raspberry Pi. And then I built the Gentoo system using the same config, just changing it from x86 to ARM64 on that Raspberry Pi, and then opened my project. And I want to say I played it, but the Pi could not play it. So I exported the project, and it exported correctly. But the Pi was not up to the task of playing the song, but it did work. And that's not a Gentoo fault. That's just a music software is hard to run fault. And then the real world example, the big example, is actually right there on the screen. Chrome OS. Chrome OS is a Gentoo distribution. Over at Google HQ somewhere on some servers is a fork of Gentoo that is building Chrome OS from source using portage and then shipping those built packages to everybody. Because Gentoo already has at the time of Chrome OS's release, ARM was really immature, especially as like a desktop OS, outside of like phones. So Gentoo was like your best bet. So Google went straight for that, and now we have Chrome OS. And
What's
then Gentoo
Kali
supports.
Linux?
Oh, Kali's a penetration testing distro. So is it a fork of Arch? I want to say that it's based on Arch. So when I say based on and fork, you guys are programmers, so you probably know what fork means, but I'll explain it. Fork is a GitHub term, well, a Git term, which means to take a project and make a second version of it, basically, right? And so when I'm saying that Kali is an Arch fork, which I think it is, I could be wrong about that. What I really mean is that they Arch Linux, and then they copied it, and then they modified it to their needs, which is super common in the Linux world. In fact, Ubuntu listed down there, which is debatably the most popular Linux distribution. You've probably all heard of it. Some of you have probably run it. Is a fork of Debian. It uses all of Debian's base and then adds a whole bunch of stuff on top of it, some of it annoying. And that's where they get Ubuntu.
So Kali is Debian based.
Oh, Kali is Debian based? Okay,
Yep.
Cool.
Yep.
That makes sense. Kali's specifically for penetration testing. So there are some interesting things about the distribution world. Kali Linux is a good example. It comes pre-installed and pre-configured with all kinds of like hacking software. I mean, it is hacking, like ethical hacking software, all ethical, whatever. You guys know what I mean. It's intended for legal use cases. But it comes with all the software pre-configured and pre-installed. Another good example is Ubuntu Studio, which is an official version of Ubuntu pre-configured for artistic use cases, music, design, video editing, all that. It's got we talked about schedulers. It's got a different kernel scheduler than standard Ubuntu, which is better for real-time use cases, along with a whole bunch of software pre-installed. It's great. Yeah. Trying to think if I forgot any part of that question. Did I? It sounds like we're fine. And then the last thing I want to touch on is immutable distros. That's an interesting thing. A good example is SteamOS. What's the other one that's like popular? Bcache OS or something like that. Anyway, it doesn't matter. SteamOS, the thing that comes on the Steam Deck. By immutable, it just means that all of your root system packages, your base system, your file browser, your calculator, your Steam install, your web browser, all of that cannot be changed by the user. It can only change in one big clump, which from a security perspective basically means that you can't get hacked in the way of having system files modified, and you can't break stuff as easily. So for a deployment case like the Steam Deck, where your end user has no clue what Linux is, you really don't want them running a bunch of system commands and installing a bunch of packages and changing stuff around because they can break their system. So instead, you just make it so they can't do that. And there you go. And then have them install packages, basically the Windows way of download them from somewhere else and put them in your user directory. Another major factor is your desktop environments. Linux lets you entirely switch out how your system looks. Well, I say Linux lets you. It lets you do literally anything. It's just a kernel, right? But these distributions almost always ship with 3 to infinity, like nearly infinity, like 20, 30 different desktop environments. The major ones would be KDE, GNOME, and XFCE, which I will show you in 1 second because I have a virtual machine set up that we'll talk about. Which great virtual machines. By the way, I'm breezing through this for the reason of I'm going to move to the virtual machine, then we'll continue talking. And I'll let you get to questions then. Real quick, what's virtual machine? You guys probably know. Going to explain it. It's like a fake computer inside your computer. Nothing can access the outside, ideally. I mean, it could get hacked or whatever. It's nearly native performance. You have to segregate parts of your system, though. Say how much RAM, how many CPU cores. The only issue is like single GPU setups. Not so great for performance. You probably won't be running your Steam games in it. Anyway, I only bring this up because I'm going to be running Debian in a virtual machine so I can show a bunch of stuff. And then we're going to talk about the terminal. So let me go over to my virtual machine. This is busing.
Jake, what are you using these days for? Did I see Nano or?
Oh, I love Nano because I type Nano and then it gives me a blank space to type into immediately, and I don't have to press any other keys. That's it. That's my whole argument for Nano. Nothing else does that. You like use Vim or Emacs or whatever, and they like open stupid screens with a bunch of stuff that you like have to do. Or they like want you to name a document or something. I don't want none of that shit. I just want to start typing.
:QW, right?
Yeah. Yeah, let me.
You can always just, I think it's like echo and then your string, and then you forward caret that into your text file, and then you don't even have to use Nano.
Yeah. Exactly.
If I was a hiring manager today, I think the first test I would do would be, can you close this window for Vim?
Can
And
you
if they could
close
do it,
Vim?
can you close Vim? That would be like my first test.
All right,
fail.
everybody, right now, type in chat how you close Vim, and we're going to send the messages simultaneously.
Something with E. It's like Control E, Shift E.
I think he jumped the
Q.
gun on his.
E
It's
is two
calling Q
letters
exclamation.
away from Q.
The exclamation mark prevents it from asking a question.
Nice.
It's so bad. Why doesn't Control C close it? Oh yeah, that's another argument. Control C close. Nano tells you how to quit it at the bottom. Shoutouts to Nano. Shoutouts to the GNU project. Real quick, my brother bought a new PC today, and Windows is awful to set up. So I wanted to demonstrate how nice Linux is to set up. So I'm gonna share this VM. Great. So when you start up Debian VM, everyone can see this, right? Yes. Yeah. Cool.
Yep, I'm seeing it.
So to install Debian on a real system, you would copy it to a flash drive and then go into BIOS and select Debian, and then you wind up at this screen. It says select a language. No, that's not true. I bypassed the first screen. It asks if you want to do a graphical install, and if you don't touch any keys for 10 seconds, you wind up here. This is a brief comparison of the Linux versus the Windows experience. And Debian is notably hard to install. Linus Torvalds, the creator of Linux, I guess I should have mentioned him. He doesn't use Debian because he thinks the installer is too hard. So that's our baseline. The guy who made Linux thinks this is too difficult. So we're English speakers. We're in the United States. American English, the best kind. Oh, so this is the net installer. So this is cool. So it's going to grab everything in real time. Any questions, by the way, while this goes, pertaining to anything we've covered so far? I just wanted to get into this because it'll take a minute. And then I want to get to the terminal, which we're not... Spoiler, I'm not going to do the full install. I have a second already completed install. So we're going to... Oh, yeah, I should show you what I'm doing. I was just clicking through because I'm because I'm so used to this. Okay.
How many
So
installs do you
before
think you've done
you
this year? Oh,
go ahead, Mike.
I was guessing over 100 installs this calendar year.
Oh yeah, I throw Debian in virtual machines all the time. We're gonna make a super memorable password that no one will ever hack. Yeah, so we make a root user, and then we need to set a username. It's gonna be demo. Name for account demo.
I was just gonna
Totally
say,
not.
if you're doing this on your actual base machine, one of the steps that you have to do before doing this is typically partition part of the hard drive.
Oh no, that's here, and I was gonna talk about that. Yeah, so when you get to this point, Debian will ask you to partition your hard drives. If you are trying to preserve a Windows install on the machine that you are doing this on, this is the critical part. First off, I would not advise sharing a drive with a Windows install. Windows loves to overwrite Linux's stuff. Linux is perfectly happy to coexist with Windows. Windows absolutely cannot get enough of overwriting Linux. So you need to put them on two separate drives. But if they're on two separate drives, you won't have any issues. And this is where you would do that. You would go to this manual section here, continue, and this would list all of your drives and their sizes. In this case, we just have one virtual drive. That's 35 gigabytes. So that's what we're going to use. So when I select it and continue, it's going to tell me it's empty and I need to make a partition table. Yours will say other stuff, but if you actually reach out to me, I can help you install this if you really want to do. Go to the new, yeah, we're going to that free space. We're going to create a new partition there. It's going to be the full size of it. It's going to be the primary. And I'm going to make one change here, which is that I want BDRFS and I want compression. We're going to label it root and make it bootable. You can make it do all of this for you, but you generally want to do this part by hand so that you know nothing goes wrong and you can keep track of what gets written where. And you finish, write changes. It's telling me that I don't have swap and I don't care. It's asking me if I want to make the changes. I do. Now it's going to start installing. And in a second, it's going to ask us one more question before the big install happens. And then we're going to switch to the other VM that's already set up. Any more questions? We got
yeah, just going with like the times, I guess. You know, you spoke about OpenClaw earlier, you know, putting it on like you know, partitioning off part of your disk for a virtual machine and spinning up your VM,
Yep.
and then putting OpenClaw on that is probably, you know, a pretty popular use case these days, wouldn't you say?
Yeah, and this is equally easy on Windows and Mac OS. Maybe not equally easy, functionally as easy. I'm trying to think if Windows makes you do anything weird.
One of the benefits though is that this is, you know, completely open free source that you just got to spend the time to set it up though, right? So you could, in theory, set up like 10 virtual machines, whatever, depending on your resources, to, you know, run as many open claws as you want on one device.
Yeah, exactly. Or as many segregated anythings you want. Basically anything but 3D applications. I'm going to give this 20 more seconds before there's one prompt I'm going to skip if I do skip this, and it's asking what desktop environment we want to install, which I was going to talk about briefly, but if this takes, basically I'm going to have one more question from someone, and if it's not done by the end of that question, I'm just going to switch over.
Yeah, just for the sake of time.
Yeah, this is running on my archival hard drive. The other one install is on a RAM disk. So it's like nearly instant speed, but this is running on a 5400 RPM backup drive. So it is slow.
So, desktop environment, as someone that was kind of raised as a Windows user, I think about my desktop environment as like the same thing as my operating system together with the kernel. And it was kind of a paradigm shift to realize that your graphic user interface in your desktop environment is really just a program that you can install. And so could you talk about some of the desktop environments that are out there?
Sure. And while I do, I'm just going to switch over to the other one because that progress bar is not inspiring faith. I don't think it's lying to me. So what is a desktop environment? So in Windows, your desktop environment, which Windows does have a desktop environment, is going to be your all of your like tools that you think of as Windows, really. So your start menu, your file explorer, your calculator, your settings menu, your desktop, your display at all, right? That should be the right new one. Yes. Is that showing up? Can't tell if that's showing up. Looks like it's not. All right, let me launch it one more time. Okay. Ah, I see what's happened. Now it's showing up. Great. Cool. You see the one that says install the grub bootloader? Yeah, so I chose the KDE desktop environment, which we will see in 1 second. But this would be the last step, is it asks about installing a bootloader, which tells the computer how to start. We want it to do that, and we want it to go into the same place that we installed our other stuff.
Yeah, the
Then
Windows desktop environment is one of the biggest gripes that people have about Windows. And particularly the start menu in Windows 11 is very slow.
Yeah, I think it's a web app.
It's a React app. And then it'll also like try to serve you like search results from the internet when I'm just trying to look for a program on my desktop.
Yeah. You could set that up if you wanted to in Linux. But basically none of the okay, so Linux has a major upside in that it's designed for and by a bunch of nerds. And so they care about stuff like the speed at which your start menu opens on a slow computer, right? Are you guys seeing the login screen? Just making sure.
Yep.
Okay, cool. I'll make this nice and big. Well, actually, it's probably better if I keep the window small for visibility. That didn't resizing it didn't break it, right? Nope. Okay, cool. So this is Plasma's like environment, right? So this whole thing is replaceable. Everything you're seeing from this point forward can be replaced. So I'm gonna type in my super secure password that's totally not the word password. We're gonna get into our first time. Welcome to the Debian GNU Linux operating system running KDE. Honestly, we're just gonna skip that. We don't need any of that. So this already probably looks pretty familiar to you Windows users. We've got our start menu here, which as you can see opens instantaneously even in this virtual machine, and isn't full of a bunch of online nonsense. Although it does have nice sensible built-in features, like if I were to say try and launch OBS, it will tell me that I can get OBS. And if I go to it, it'll open OBS in the software store. I can click over here and install it. Type my password. So it's
What's
helpful.
OBS?
Open broadcast software. It's just for streaming. It was the first program that came to mind, but here it is. It works. We've even got a mic into this virtual machine. That's cool. I didn't know that my mic would arrive here. which is actually good for OpenClaw use cases. Yeah, so actually, let's do that. No, let's talk about Linux really fast. First, I'm going to switch the theme to dark. Oh, yeah, there we go. Yeah, so here's KDE's desktop environment, right? Oops, I resized the window. I tried to use a shortcut. It's very Windows 10, Windows 7, right? You've got your file browser, looks like a file browser. You've got a whole bunch of whatever. This isn't really supposed to be an ad for KDE. I just kind of wanted to demonstrate how straightforward and familiar things will look, right? So if I wanted to say compress my downloads folder, here you can make a zip of my empty downloads folder. There it is. We can look in there. Oh wow, it's empty. All your normal desktop stuff works. We got Firefox. Firefox will do Firefox things. So I just wanted to go through for 1 second and demonstrate without the terminal that doing your typical desktop stuff's actually pretty simple. But now we're going to move past KDE for a second, and we're going to talk about the terminal. I'm actually going to just full screen this. No, that's not my full screen shortcut. What's my full screen shortcut? Whatever. Oh, it's probably getting eaten by the VM. Yeah. So this is the terminal. This is everyone's most feared part of Linux. Oh, actually, here's what's going on. Yeah, that's way better. Yeah, I wasn't scaling the display with the VM. Now everything's way sharper. I don't know if it's sharp for you guys. It might still look terrible over the stream, but this is the Linux terminal. Specifically, this is Bash. You can see we're over here demo Debian. Let me make this huge. There we go. Let's talk about the terminal. The terminal is how you interact with the core of your system, right? You can do anything from basic stuff like I could run Firefox from here, and Firefox will open. Or I could run the ls command to list the files in this folder, right? This is your core way of interacting with the system. Really, everything else at the end of the day functions through the terminal, right? Like down here, when I click on this Firefox web browser icon, what that actually does is it sends this Firefox command like that to a terminal somewhere in the background of the system, right? It's like a not literally imaginary, but you can think of it as an imaginary terminal. And it's how all of your commands run, right? It's how all of your programs run. It's how all of your system gets interacted with. So let's clear this out and let's talk about a few basic parts of it, and it'll start to make more sense to you. So our core commands, what we use for really doing our basic stuff, are ls, which lists the documents in the directory we're in, pwd, which lists which directory we're in, and cd, which lets us move into other directories. And you can see here we're getting a nice description of where we are apart from this. Any questions? I'm going to actually get the PowerPoint imported into here and get it open so we can reference it while we go.
Yeah, I was going to say, if you wanted to continue through the slides, just for the sake of time, 15, 20 minutes. Yep.
So I'm trying to figure out where I saved this PowerPoint. Pipeline. There we go. I probably can drag and drop this to the desktop. Think that'll work. Yes, great. Oh yeah, so you couldn't see that, but I just drag and dropped that from my computer into the VM, and it showed up in my downloads folder, which actually perfect. We're in here. Now if I run ls, you can see that my presentation's in here. Let's get that open.
And Jake, John, something that I think a lot of people are seeing is grep. So how does grep differ from ls when you're running those
Oh, sure.
commands?
So
I think that's yeah.
let's go back to the slide and let's go through this. And I'll get into grep. Grep's a good command I should mention. Because I left out pipes and whatever. We'll get to it. The terminal, yeah, it's the power user tool of Linux, right? Functionally, I explained this, but it lets you, it's a system agnostic way, a distro and system agnostic way to access the core of the computer, right? So it doesn't care if you're running on a Raspberry Pi without a desktop or if you're running on a 5090 playing the latest, I don't know, Call of Duty or whatever, right? It lets you interact with the system in the exact same way, regardless if you're in KDE, GNOME, all the desktop environments, or any of that, right? Which means that once you get to know it, you can be very efficient at moving around any Linux system anywhere, plus a whole bunch of other systems. Like macOS uses most of these commands, or will support most of these commands. BSD, I don't know, a whole bunch of weird ones. There's proprietary things, but these are what you call Unix for the most part, and POSIX, two random words I'm not going to explain. So let's go over a couple really basic commands. I mentioned a few of these already. ls, which lets us list files. Move, here, let me see all these. Move, CD, and touch. Okay, yeah, those are all good ones I should talk about. So we're in our downloads right now. We clear out of this. I list it. We can see that we have one file in here. We could make a folder for it. We'll see if this crashes my PowerPoint, actually. This is probably a bad idea. Let's copy it. So the makedir command is a make directory. You can see that there's two separate colors here. There's white, which tells us this is a file, and blue that tells us this is a directory. We can also add flags to the command to get more, I want L, more info on them. So we can see who owns the file, what group owns the file, what permissions there are, all this fancy stuff Linux is doing in the background. That's all mainly security stuff. Sorry, I'm a little bit thinking on where to. Okay, so let's talk a few more basic commands. So cp is copy. It lets you copy a file. It takes an input that is a file name, and it will make an output, whatever we call it. So now when I list files in here again, you can see that our copy has shown up. Move lets you move files around. If I move the copy into the... Oh, I'm pressing tab, by the way, to make these fill out. That's just a function of most terminals. It'll autocomplete what you're typing for you, which is very nice. This tells us, so the slash tells us to go into a folder, and this dot tells us to place it there. That tells us where we are. Right, so if I run this, I list again, we can see it's not there. We move into our PowerPoints directory, and we list it, we can see our copy now is there. And then we can use rm to remove it. Now it's not there. You can see again. We can use rmdir to remove our PowerPoints directory. We're back to just our presentation. That all makes sense. You guys are all techie. I figure these commands are all sensible to you, so I didn't want to like sit here and baby you through them.
We're with you.
Great. Files. Let me drink some water. Everything on Linux is a file, and I mean everything from your files, your folders, your network, your hardware, everything. Your software runs as a file. Hang on. And they all exist on our file system starting at /. So let's go back to our terminal. Let's clear out of this. And I am actually going to become the root user. Actually, I'm going to do something really quick. I'm going to install a nicer terminal so that we don't have to sit here and suffer through stock bash for the rest of this. Great, looking sharp. I'm now root. Root is your admin account. Root can do anything. Literally nothing can stop me. I can delete the entire system right now. Nothing will complain. Nothing will do anything. It's truly the admin account, which does not actually exist on Windows and Mac OS. They both have the administrator account, but it's actually quite locked down. Sensibly so. It's not necessarily a dig on these systems. It's just a fact. I'll full screen this again. But the root user here can do anything. They can see anybody's files. They can modify anything. They can do it all. So by default, they have nothing in their folder. That's not important. We're going to talk about /. / is the root of where all the files are. You can see we have a bunch of interesting folders and interesting colors, and some of these have A symbols on them. Interesting stuff. We're going to talk about a couple of these folders right now. Bin alphabetically is number 1. That is where your system binaries live. These are where core commands, I guess you would say, exists. Commands that administrators of a system would want to run. So this is where things like ls to list files are, or wc gets the word count of something. ln creates a symbolic link. ld is the linker. LDD is specifically the linker. This @ symbol means that it's a symbolic link. I mentioned links. This is basically bin is where all of your important system processes run, right? And we can find out where a program actually is with this command called which. So if I say which ls, it'll tell me, oh, interesting, it's in user. Mount. Oh, okay. Oh, I see. Debian's linking the bin. Oops. There we go. Yeah, okay. Debian is just making a symbolic link from bin to user bin. So these actually are the same as far as the system is concerned. So links are fake files that point to other files. I didn't realize that Debian did that for its entire bin folder, but that's interesting. Yeah, so bin is where all of your binaries live. That's all it stands for. That's where programs run. So when you run a program, it'll run in there. In this case, it's running in USR bin. The USR is the Universal System Registry. That's where when I install programs, they go. That's basically its point. When you run apt to install a program, that's where it goes. Any questions? I'm going to stop for 1 second.
Nope.
Cool. I figured people are a bit familiar with Linux, so I just wanted to breeze through these in case anything catches somebody. Back to the rest of /. So then boot is like it sounds like. That's where your kernels live, and that's where your bootloader lives. That starts your system. We can actually see Linux is right there. It's this file right here, VM Linux 6.12.90 deb13. That's the actual Linux binary that we're running right now. Uname tells us that. So that's where it resides. That's where it loads from at startup. Etsy. Etsy is your configuration folder. This is where all of your settings go, so if we go, I don't know, file system table, you can see at startup, I mentioned that or when we were installing this, I mentioned that I made my root BDRFS and I added compression to its boot options. This is where that happened, is right here. That got modified, and now when Linux starts up, it looks at this file in etc fstab, which is file system table. It sees that the root drive is BDRFS, and it sees my compress option. So that's your etc. You can see there's a whole bunch of stuff in here, right? So here's where our Firefox configs sit. Oops.
I can attest to the fact that at one point I installed Debian on a Chromebook, which is a very, very small computer, and it was a little bit challenging. And one of the things we did to free up the extremely limited hard drive, I think the whole computer's hard drive was like 15 gigs, and Debian 12 or 13 was like half of that, like 7 gigs. And we use that exact process to compress the entire hard drive. And that that freed up like another 30%, which was really
what in the
huge.
world package? Oh, of course it's BDRFS comp size. Yeah. Sorry, this is to demonstrate. So if I list my disk usage for the root directory, we can see down here 7 gigabytes of data is used, but that's not actually true. If I look at it with comp size, how do I search my entire root? Do I have to? Oh, I see. It's because of proc. This work? No files. Okay, so 6 gigs of it lives in the USR. So that's pretty much where everything is in the Universal System Registry. So if I see how much it's actually using on disk, you can see that it's only actually using 3 gigs on disk because the rest of it is getting 1.5 gigs is not getting compressed, just didn't benefit from compression for whatever reason. But the rest of it, the other 5.7 gigs was reduced down to 3.1 gigs just for free. And you can see it's clearly not affecting performance. Like everything's flashy. I guess that's a fine word. Yeah, everything's quick. So it's just free space if you have a modern computer capable of handling it. And you can adjust it. You can make it way more compressed if you didn't care about disk speeds and really just wanted to save space. And there's even cooler stuff. Like there's this option, reflink, which BDRFS supports, which creates a file reference link. So it makes a fake copy of the file that becomes a real copy of the file when the file is modified, right? So if I make a 1 gigabyte file, or let's call it a file. Now I'll make it 2 gigabytes. So if I make a 2 gigabyte file, I should have.
You're going to give it an extension?
Yeah, so this is an interesting thing to talk about here. So this file right here, this dev urandom, is actually fake. It's not a real file on the system. So if I list dev this is where all of your devices are. So you can actually see some really interesting stuff in here. VDA is our drives, right? If I list my disk free, you can see dev VDA is our root drive. That's a file on here, right? We can interact with that as if it were any other file, right? So I can, DD lets you take files and write them elsewhere, right? So I can actually take our current disk, and just send it into oblivion. It won't do anything, but right now it's reading the entire disk and copying it into another fake file right here, which is dev null, which just gets any data sent into it, just goes into oblivion without returning an error. So right now I'm inputting my entire hard drive and I'm outputting it into there. You can see it'll go through. I'm just going to interrupt it because it's not actually going to do anything. But that actually leads you to interesting stuff you can do, right? So to make a backup, which you wouldn't normally do for a live drive, you would use an offline drive for this, but you could take that file, right, of your entire hard drive. Actually, let's we've got this A file here, which is completely random data. Right, it's a 2 gigabyte file of, this will be fun. I should have thought about that before I opened a 2 gig file with Nano. I'm watching my RAM fill up in real time. It'll get there. Is it going to get there? Do I have to kill it? Okay, all right, it killed itself already. Yeah, it's just a bunch of random stuff, right? I have to kill this terminal now because that'll be broken. Okay. Oh, yes, I remember. Yeah, so because everything's a file, right? You can do very interesting things. So I can treat this brick of random data as if it were a drive in the same way I can treat my drive like it were a file, right? So I can make file system. We'll make it BDRFS. BDRFS is a good form. The file, it's going to complain to me. No, it didn't complain to me because it saw that it was completely random data. Yeah, cool. So it ran, didn't complain. Now, there we go. So now that I ran this file, sorry, I had to make the drive point. Now I have a fake drive at mount fake drive. You can see it's loop 0. It makes itself a fake device. That's 2 gigabytes. And now I can write data into this file here. Right. And there it is, some text. And then I can unmount this file. I can't. Oh. Right. And now it's just stored inside here, and I can do things to it as if it were a normal file. And then I can remount the modified version of it. Go back. And there's our text. Oops. And it's survived. So like because everything's a file, nothing gets treated differently. The only issue is permissions. So I have to be root to do some of this, not all of it.
Is sudo the same thing as root?
So sudo is a program that actually reminds me I should. What's our guy's name? Demo. All right. I had to add, okay, so this command right here, user mod, make modifications to a user, AG is additional groups, sudo is the group name sudo, and then demo is our name. So that is a big command that says that the demo user is going to be added to the sudo group. Sudo is an interesting command that lets you, oh, I have to log out and log back in for it to work. Crap. All right, so we're not gonna fully demonstrate it. My bad. Because it'll take my password and then tell me I'm not in the sudo's file. So I had to use su, which is switch user, which is basically the same but not. So sudo super user do lets you run commands as the super user as another user, but it also lets you run commands as any user. So you can use the -u to make it the demo user, and then I can do -i as an initialized shell. And now I'm the demo user again. And then if I log out, I'm back to root. If I log out, I'm the demo user again. Password does the same thing. Or not say, yeah, sorry, not password. SUL, I said what I was typing. SUL does the same thing. This is all just to change user accounts, is basically what this is doing. Back to interesting stuff. So let's look at dev a little bit more. We have TTYs are your terminals. That's pretty funny. I'm trying to think. Here's your CPU, and then this has 6 CPU cores. You can see them here, 0 through 5. We can look at CPU 3. I think I can. Let's see what this does. Nothing of value. Okay.
And then John,
I don't know how to interact with a ton of these files, so I'm not totally sure. They're not normally stuff you don't normally do much in dev outside of access disks and a few other things like I mentioned the fake files. So if strings is a command that'll just dump the output of a file to the prompt, right? So if I strings the presentation, right? It'll just dump the presentation as a bunch of strings to the terminal. So there's some interesting files that are fake files in dev. There's dev0, which is just an endless string of nothing. There's dev null, which I talked about, which is an even more endless string of nothing. You can see it just cancels out. Then there's urandom, which is a pseudo random generator. So now we're just going to get an infinite amount of random strings. That's what I used to make the fake file earlier, but you don't have to. You can.
Hey, we got like 5 minutes left.
Yes,
do you want to
major
talk about...
thing I want to talk about, which is pipes, actually. Before the last concept in Linux, I think everyone here should know as LLM users. And then we'll go on to raw questions anyone can leave, and I'm going to install Hermes on here and make Hermes do stupid stuff while anyone wants to hang out for a minute. But we're going to talk about pipes. So there's a couple types of pipes, right? So right now, this command is just going to output a bunch of random text to the terminal. I don't want to do it because it'll break. We can use this caret to say write it to a file. We've already done that, so we've put a file here. I'm going to wait 2 seconds. All right, cancel it. Now we have a 400 megabyte file here called a file. You can see it right there. You can see because that's what got copied was the 403. Not that interesting. What is interesting is, or actually, no, that is interesting. Sorry. This single caret will overwrite the file, right? So if I do this and I let it create a file, we cancel it and it makes 417 megabytes, right? And we check it and it's 417 megabytes. If I do this again and I cut it short, now it's only 84 megabytes and we check it, it's 85 megabytes. If instead I run it, let's get a decent sized file. And it's 500 megs. If I instead use a double caret and we cut it short, we only added 130 megabytes to it, but you can see that it's 650 because we appended it. This double arrow says append to the end of instead of single arrow is just overwrite. You can also use arrows back. Echo will repeat anything you put into it back to you. So we can send that to a file.txt. Oops. Right. And then we can echo from a file.txt. No, we can't. I might be retarded. All right. I don't know how echo works. Never mind. You're supposed to be able to do that, but I don't remember how because I never do that. It's just not a normal command I use. It's totally normal for other people. But going back, so we can write to a file. Actually, this will be even easier. So if I nano this a file, we can see we wrote hi in there. If I do this, you can see it gets overwritten with hello. But if I double arrow it, now we get hello, hello. Great. Let's remove both of those. Now, the most powerful pipe. It's this beauty right here, this big vertical line. That just says take the output of one command and send it to another command, right? So I can go echo hi, pipe that into, I don't know. Let me actually make a file. Right. Cat will read a file to the command line, so we can see cat reads hi back. We can use this to send it into something else. What's a command we can send it into? Crap. Whatever. Copy won't work with it. We're going to do something actually interesting. So I'm going to make a directory called a dir. Inside here, there's file 1, file 2, and file 3. We can see them, and we can see a dir. I'm actually going to make one of these files full of some nonsense. Great. And then another one of these files full of all zeros. Great. Now, let's one more command, PV, which is pipe viewer. Pipe viewer lets us see how much data goes through a pipe. Now, finally, I can actually do something. So tar will let us, it's tape archive. It'll take all of the files and write them to a single string so that we can do something with them. Tar cf dash, and then the file name. And we're going to output that into PV, which is our pipe viewer. That'll tell us how much data is flowing through it. And then we're going to output that into XZ, which is a compression algorithm. I'm going to tell it to run with max compression. We're going to make a dir.tar.xz. And we're going to run this command. And we can see it's going at about 60 megs a second. Slowing down because tar is thinking really hard. Great. Now we have a file created, this adir.tar.xz, that contains all of a dir. because we piped it from this C into our pipe viewer, which told us how much data went, into XC, which compressed the file, which is how we went from 650 to 120 megabytes. And then we used our caret to output it. And what did we output it to? adir.tar.xc. And then we can go, oh, this is in the root user stuff. I just run Dolphin. No, I can't. Okay. But I'm gonna get blocked for. Let me copy these into. Okay, cool. Here they are. So you can see here we've got a dir, which has our files in it. Very nice. This one is empty. This one is full of 100 megabytes of junk. This one is full of 500 megabytes of zeros. Then we have our compressed version, only 121, which we made from our pipes in our command line. And you can see inside here, it's got all of our directories and files. So pipes are probably the most powerful aspect of the Linux command line, is your ability to do something and send the output of it into another. Jake mentioned grep. So I'm going to give one example with grep real quick, and then I'll take any questions and we'll just consider it done, and I'll do nonsense in the background while you guys ask me anything. Find will list all of the files, right? So this is the entire directory tree. We take that, and we output that into grep. We tell it not to, which is something regular expression. I don't know. It's going to search through everything for whatever string we put after it. So if we search for Firefox, it's going to find us where all of our Firefox stuff is. So we can see we have a Firefox. Oops. We have a Firefox profile in our home directory with some stuff. I'm going to highlight it. So that's kind of the use of pipes, and we can see it's in our etc as its general config, right? It's showing us our entire drive. And we could even run that into a second one, because say we only want to find JSON files, right? So we grep a second time for .json, and now we're only finding things that match both Firefox and have .json in them. And that's just pipe into pipe. And there's a lot more to pipes too, but I wanted to cover that concept. Any questions? Let me look at your beautiful faces. There you all
Thank
are.
you, John.
I've not been
I'm
able to
going
see.
to stop the recording, but we can still ask questions. So